This presentation is delivered by the Stanford Center for Professional Development.
It's time to launch into an entirely new topic, and the entirely new topic is something that we refer to as enumeration. Enumeration is a pretty basic idea, and it kind of comes from the word enumerate, as you can kind of imagine. When you enumerate something, you basically just have some way of referring to something through numbers. So if we wanted to enumerate, for example, the year that someone is in college, we might have freshmen and sophomores and juniors and seniors. That's just an enumeration of the year you might be. And so the basic idea is we just want to have some set of things that we enumerate or give a set of numbers to, essentially. And you don't necessarily want to think of it as having to be a set of numbers, but it's basically just some set of items that go together. And so we generally give them some numbers or some listing as a way of keeping them all sort of, a way we might keep track of them. And so one way we might do this in Java, for example, is just to have a series of constants that are integers. And so just to save myself a little bit of time in writing, constants, yeah, beautiful thing. So we might have some constant, public, static, final, int, and so if we're going to do an enumeration, oftentimes we just use integers to refer to each of the individual items, and we just count them up. So frosh would be 1, sophomores 2, juniors 3, seniors 4, grad is 5. That's just what year you might be in school. Oftentimes as computer scientists we actually start counting from 0, but sometimes it actually makes sense to have these things be numbers that start at 1. For example, if you want to know which year someone is in school, or if you're doing like months of the year, January is generally number 1 as opposed to month number 0. So just to keep it with common parlance, we might actually number it this way. Okay? Now there's something that was introduced in one of the later versions of Java, Java 5.0, which is kind of the second to latest version, which is something called enumerated types. And the book talks about them briefly. I'm not going to talk about them here, sort of for the same reasons the book doesn't talk about them much. The book actually talks about them and then says the advantages and versus disadvantages of doing enumerations using this thing called an enumerated type versus just listing them out as integers. This way, at least for the time being, in sort of the development of Java's world, seems to win out. So we're just going to teach you this way. As a matter of fact, in the old school, anything before to Java 5.0 had to do it this way. So it's just best that you see it this way, because most code right now these days is written this way. And it probably will continue to be until at some point this new enumerated type thing takes off. But if you see in the book, it talks about enum type. Don't worry about it. We're just going to do it this way. Now, the only problem that comes up with doing something like this, though, is that you want to figure out, well, how do I read in these things and display them? Well, these are all just integers. So if I actually want to ask someone their year in school, I would have to keep track of that with some ints that I might call year. And so I would read in an int, and I might ask the person for their year, for example. And when I read that in, that's all good and well. The only problem is this thing is just an integer. Right? The user gives me some number, hopefully between 1 and 5. I might want to actually have some logic in here that checks to make sure they gave me a number between 1 and 5. Because if they gave me a 6, I don't know what that corresponds to. Maybe that's the dreaded other student category or whatever. But I need to do something to guarantee that it's in this list 1 through 5. The other problem is if I actually want to print out someone's year, there's no way for the computer to know that year 1 should print out the word frosh. So if I do something like println here, and I just write out year, that's going to write out an integer. It's going to write out a value, whatever value the user gave me, presumably between 1 and 5. So if I actually want to have some nicety in there and say, oh, you know what, if the year is 1, I actually want to write out frosh as opposed to writing out a 1, I need to do that manually. So somewhere in my program, I need to have, some function that I do a switch statement, or I can do cascaded ifs, and I switch, for example, on year, and I might say, well, in the case where year happens to be frosh, right, I'm just referring to this constant, which is 1, then what I'm going to do is actually print out println frosh in quotes, right, because that's the only way the computer knows about it. And then I would have a break, right, the funky syntax from our friend the switch statement. And then I might have some case over here for sophomore, dot, dot, dot. And so I need to do this manually. And that's just the way life is in the city, okay? So these things are just integers. We have some enumeration. So in the program, right, the program can read a little bit more like text because we can refer to frosh, sophomores, juniors, seniors, grads, the whole thing as constants in the program. But when it comes to displaying them on the screen, we need to actually write it out manually because the computer has no other way of knowing that a 1 means frosh. Huh? Well, case 1 is the same thing as case frosh, because if these are in the same program, frosh is just the constant one. And so, in fact, that's why we want to refer to it that way, because it's more clear for someone reading it. They see, oh, what do you do in the case where you're a frosh? Well, I'm going to write out frosh. You know, it's fairly straightforward enough, but I'm just using these constants. So if someone else wants to come along and say, you know what? Yeah, you know, I love frosh, and they're all great, but I'm a computer scientist. I start counting from 0, right? Well, it'll just change everywhere in your program as long as you've used the constants if you're referring to 0. Okay? And they might just say, well, actually, frosh are the coolest. They're a 6. Right? And we'll just leave, you know, that's fine. You can do whatever you want. The computer really doesn't care. All right? Most people probably won't care either. So we just start counting from 0 or 1 most of the time. Okay? So any questions about the general idea of enumeration? Uh-huh. Well, that's the thing. In your program, you want to set up the expectation that they're entering a number. Right? If they were to enter the string frosh, because readInt does error checking, it's going to say that's not the right format. So one thing you could actually do is you can, rather than reading an int, you can read in a line, which would read in a string, and then you'd need to have some logic to convert that over to 1. So you'd sort of do this process, but backwards. So that's why enumerations are something that are useful to have when you're writing real programs, but they can get a little bit bulky to use because you have to do these conversions. Well, right now I'm just making the constants public because I might want to refer to them in some other class, right? So if I have some other class, I can also refer to these constants. If I was only going to refer to these constants within this class, I'd make them private. Alrighty. So with that said, it's time for something completely different. And I know like the sun isn't out very much right now, but I sort of had this thrill where I wanted to barbecue one last time. And I figure if I can't barbecue outside, I'm going to barbecue inside. Now, I wanted to light a fire in here, but as you can imagine, for various reasons, that was frowned upon by the university. So I can't actually light the fire, but I can basically do everything else that would be involved with grilling, which doesn't really turn out to be that exciting when you don't have a fire. But the basic idea is, right, if I leave some things on the grill for a while, now these get a little hot. You got to just pretend they were on the fire for a while, okay? If you leave something on the grill too long, what happens to it? It gets kind of burned. It accumulates something. It accumulates something we refer to as char. Okay? And so it turns out, as a computer scientist, you get a different kind of char that other people get on their burgers when they're grilling them, or as happens to be the case, on their ding-dongs. Turns out they don't make ding-dongs. How many people know what a ding-dong is? All right, good times. If you don't, come and look at the box. It turns out they don't actually make ding. I probably can't even show the box. I'm sure this is copyright Hostess, 2007. I went to like so many places last night trying to find ding-dongs, but you can eventually find them. The basic idea, though, is we want to think about something that we want to refer to in a program that isn't always just a number, right? So far, we've been dealing with a whole bunch of numbers. We had doubles, we had integers, life was good. I told you about this thing called string, but we didn't really explore it. And now it's time to explore it a little bit further, to figure out what these little puppies, these little chars, or little characters are all about. Okay? So what we're going to do is we're going to explore the world of char. Yeah, because when I grill, I wear khakis. That's just life in the city. So there's a type called char, which actually is a character. Okay? And so the way we refer to this type, even though I just called it char, is we don't call it a char. We call it either a char, like the first syllable in character, or some people call it a car, even though it's not called a character, because they just look at it and they're like, oh, if it was one syllable, it would just be car. And some people look at it and say, no, Mehran, if it was just one syllable, it would be char. Don't call it char, I will beat you. Just like, he threatened me with violence. No, that was a joke, by the way. If anyone's like, I know it's going to show up like on YouTube somewhere, and they're going to be like, oh, this professor threatens his class. Joke. It was a joke. Yeah, and I'll be trying to explain that to the judge when I'm in jail. And he's like, well, the video I saw didn't appear to be a joke. All right, so car is just a character. We can declare variables of this type, right, by just saying car, and I'll call it ch, right? So I have this little car ch. And what do I assign to these puppies? What I assign to them is something that's inside single quotes. That's the key. So I can say something like ch equals little a, and I put the a inside single quotes. Not to be confused with double quotes. If I put it in double quotes, that's a string. That's not the same thing as a car. So I put it inside single quotes. That indicates that it's a character. The other thing that differentiates a character from a string is that a character always is just a single character. You can't put more than one character there. It can't be like CH equals AB. That's not allowed. It's just a single character. Now, the funky thing, and you might say, so Mehran, why are you telling me about this thing called characters right after you talk about enumerations? Because it turns out in the computer, right, the computer really doesn't know about characters in some deep way that you and I know about characters, right? All characters inside the computer are actually just numbers. At the end of the day, we can refer to them as these characters and they're niceties for us, but to the computer, they're actually an enumeration. A happens to be some number, and B happens to be some number, and C happens to be some number, and so now it's time for you to know what those numbers are. So if we just look at the slides real briefly, there's this thing called ASCII, which is ASCII. Anyone know what ASCII stands for? Free candy. Yeah, it's the American Standard Code for Information Interchange. And we'll just kind of do it as a social. And so the basic idea for this is that somewhere, some time ago, someone came along and said, we're going to create a standard enumeration of all the characters that exist. And so here's the first 127, as it turns out, character enumeration, which is the part that's mostly been standardized. All the rest of the stuff there's still some debate about, but this one everyone's standardized on. Now, this little diagram that's up here is actually in octal numbers. And you're like, octal numbers, Mehran? Yeah, it's base 8. Just computer scientists think that way. We think in base 2, we think in base 8, and we think in base 16. You're like, yeah, most people think in base 10, Mehran. Yeah, that's why most people aren't computer scientists. So here is base 8, right? Although they should be. We should just cut 2 fingers off, everyone. Then we'd count. I had this roommate once, a long time ago at Stanford, who thought everyone should count in base 12 because like 12 was divisible not only by 2 but by also 3 and 4, and 10 wasn't. And he would just like try to convince people of this all the time, and I was like, that is so wrong. And now he like is actually like works for the Senate, which I wouldn't be surprised if we have some resolution someday. It's like the United States will now count in 12, base 12. But anyway. The basic idea here, as you can see in this, is that first of all, like the character A is not the number 1. And there's actually a distinction between the uppercase A and the lowercase a. Another thing that's also kind of funky is you might notice the numbers up here, like 0, 1, 2, 3, the digits. The number 0 is not the same thing as the character 0. The character 0 just has some enumeration that's some funky value. Who knows what that is, right? It's this. It would actually be 60 in octal notation, right, which turns out to be 48, right? That's not the same thing as the number 0. So it's important to distinguish that the number 0 that we think of as an integer is not the same thing, so I'll just write not equal like that, as the character 0 when we would put in single quotes. And that's true for all digits, okay? And this chart you don't need to memorize, right? You don't need to care about what the actual numbers are. If you really do care about memorizing it, the way you can read the chart is the row on the chart is like the first 2 digits, and then the third digit is given by the column. So A is actually 101 in octal notation, right, if you really care about reading this, right, which makes it the value 65, but we don't really care. We just think of it as A inside, capital A inside single quotes. Now, there's a couple things that gives you, though, that are useful. And the couple things that it gives you that are actually useful is it guarantees, let's write it over here, that the letters little a through little z are sequential. It guarantees that uppercase A through uppercase Z, I'll just write it real big, are also sequential. And it guarantees that the digits 0 through the digits 9 are also sequential. That's all you really need to care about, right? Other than the fact that these guarantees are given to you, you don't care about what the actual numbers are up there, all right? There's a couple other things that look a little weird up here that I'll just kind of point out. There are some characters that are like these backslash characters, like backslash T and backslash N. You're like, Mehran, I thought a character was only like one thing, right? What are these backslashes? Those are just special characters that are treated by the computer as a single character. So backslash N is new line. It's like a return, comes down to the next line. Backslash T is the tab character. And if you're really interested in all these things, you can look them all up in the book. But those are the only ones you need to know, okay? You might wonder, hey, Mehran, how do I get a single quote, right? Because if I'm trying to put characters inside quotes, if I want little ch over here to be a single quote, do I write it like 3 quotes in a row? No. That will confuse the computer to no end. The way you actually do it is you put in a backslash and then a single quote and then another quote. And this is what's referred to as an escape character. when it sees a backslash, it says treat the next character as a literal character, not as any special symbol that, for example, closes the definition of a character or something. So this whole thing is just the single character apostrophe or single quote, and it's inside single quote, so that's how it knows that this is supposed to be the character single quote as opposed to the closing of the character. A couple other things that are sort of funky. And what happens if you want to actually do a backslash? Because you might say, but if I see a backslash, doesn't that mean the next character is something special? Yeah, backslash is actually just backslash, backslash. Kind of funky, but if we put that inside quotes, that would be the single character backslash. There's a couple others that are worthwhile. Double quote, same thing. We would put a backslash and then a double quote if we wanted to have the single double quote character. Not a huge deal, but you should just know that if you want to put like apostrophes inside some text that you're writing or something like that. Okay? So, how do we actually get these characters? How do we deal with them? Okay? Rather than getting single characters, right? So before we talked about over here, like our friend read int, right, which reads in a single integer. You might say, hey, do we have a read char? Like, can I read a single character at a time? No, not really. Not so much. So what I end up doing is I read a whole line at a time from the user, and then I can break up that line. So I'm going to have some string, and that string s, I would read a line from the user, and that's going to be a whole bunch of characters that are stored inside that string s. And now I can pull out individual characters using something called char@. So I can say ch, or char ch equals s dot, and so the string class, or the string objects, have a method called char@, and you give it a number, and it gives you the character at that position. So I could say char@, and as computer scientists, we always start counting from 0. So I can say char@0, and that's the very first character in the line that the user actually entered. Okay? I can do a println on that character directly, and it'll just write out that first character. Okay? So the way to think about this is, let's say I read a line, S, and the user gave me a line, and they typed in hello. Okay? And then they hit enter. Hello gets broken up into a series of characters where this is character 0, 1, 2, 3, 4, and that return that the user types just thrown away. It's cleaned up for me so that it just gets rid of it automatically. So if the length of the string that the user typed in is 5, it's actually indexed from character 0 to 4. So char@0 would give me the H character out of here. That's just a critical thing to remember. We start counting from 0 as computer scientists. Okay, any questions about that? So we have our friend over here. Let's see if I can actually get this all the way out of the way. Woohoo! We have our friend over here that tells us, hey, the number or the letters are guaranteed to be sequential in the lowercase alphabet, in the uppercase alphabet, and the characters of the digits 0 through 9. So how can I use that? It turns out you can actually do math on characters. And you're like, oh, Mehran, the whole point of having characters was that I wouldn't have to do math on them. Well, you can actually do math on characters. It's kind of fun. Let's say we want to convert a character to a lowercase character. Okay? So we might have some method, public, it's going to return a character, which is the lowercase version, I'll call it toLower, of whatever character is passed into it. So it's passed in some character ch, and what it's going to return is the lowercase version of that character. So the first thing it needs to check is, hey, did you give me an uppercase character, right? Because if you give me like an exclamation point, what's the lowercase version of an exclamation point? Some people are like, period? No. We can't lowercase punctuation. It just doesn't work. That's like, what's the lowercase version of a period? Comma. What's the lowercase version of a comma? Space. What's the lowercase version of a space? Yeah, somewhere it stops, and it stops here. Yeah. Yeah, you're like, no, yeah, we just get rid of the spaces. Yeah, well, then it's not a character. All right, so how do we check that this thing is uppercase? Well, these are really numbers, and we're guaranteed that they're sequential. So we can treat them just like numbers. We can do operations on them like they were integers. We can say if ch is greater than or equal to uppercase A, and ch is less than or equal to uppercase Z, if it falls into that case, then we know that it's an uppercase character because they're guaranteed to be sequential. And if it doesn't fall into that range, then we know that it's not an uppercase character because it's outside of the sequential range of uppercase characters. Okay? So what do? We're going to return something which is the lowercase version of that character if it's an uppercase character. How do we convert it to lowercase? Anyone want to venture a guess? And your prize will be Ding Dong C, not reflective of your grade in the class. Yeah? We could. How do we know how much to add? It's on the chart, but we don't want to use the chart because we don't have to remember what's in the chart. Ah, yes, for that, A. It's the difference between the uppercase and the lowercase character. So think about it this way. First thing we want to do is figure out, I'm going to explain it a slightly different way, which is first we want to figure out which character of the uppercase alphabet you typed. So we take the CH you gave us and subtract from it uppercase A. Okay? If we do that, if CH was uppercase A, we get 0, which is the first letter of the alphabet. If it's B, we get 1. If it's C, we get 2, etc. This will give us, in some sense, the number of the letter in the uppercase alphabet. Once we get that number, we need to say, figure out what the corresponding letter is in the lowercase alphabet. So translate, according to that chart, into the lowercase alphabet. I don't want to memorize that chart. How do I know the starting position of the lowercase alphabet? It's lowercase a, so I just add lowercase a, which is the same thing, basically, as taking the difference between the lowercase alphabet and the uppercase alphabet. But if I do that, basically, this portion tells me figure out which letter, in terms of the index of that letter, and then offset it by the appropriate amount to get the corresponding letter in the lowercase alphabet, and that's what I return. Otherwise, well, what happens if I'm not in the uppercase alphabet? I just say, hey, I'm going to give you back. You wanted lowercase version of exclamation point? Not happening, buddy. You get exclamation point back, right? Because I have to still give back a character. I can't say, I'm going to give you back, like, this big, giant goose egg. And it's like, sorry, thanks for playing. I can't do that because goose egg is not a character. So I just return CH unchanged. Okay? So we can do a little bit of math. It doesn't matter, right? I just get the offset. But I'll still give you a B for that. Good. That's like B for effort. All right. So the other thing we also want to think about is we can not only do this kind of math on characters, we can even like count through characters. You're like, oh, Mehran, counting? Oh, yes, it's so much fun. It's just like when you remember in the days of yore when you learned your little alphabet, like the little alphabet song, A, B, C. Do you remember that? I thought for like 5 years of my life, element of P was one letter. Just totally screwed me up. But that's cool. That's just the American educational system. All right, so if I have some character like CH, I can actually have a for loop counting through the characters. I can say start at uppercase A. As long as the character is less than or equal to uppercase Z, CH++. I treat it just like an integer. And now what I have is a for loop that's index is a letter that counts from uppercase A through uppercase Z. I can do this lowercase. I could do it with the digits from 0 to 9. But I can treat these things basically just the same way I treated integers because underneath the hood, it's an enumeration. They really are integers. Okay? So other kind of things to keep in mind is characters are a primitive type. So characters, this type char is like an integer or like a double. It's referred to as a primitive type. It's not a class. So you don't get objects of type char. You actually get these low-level things called char in the same way you got integers, which means when you pass characters, you get a copy of the character. It also means that a character variable like CH is not an object, so it doesn't receive messages. It can't get messages. But it turns out there's a bunch of operations we'd actually like to be able to do on characters. And so Java gives us this funky class called character. And character in it actually has a bunch of what we call static methods. They're methods that you can apply to characters, but you don't call them in the traditional sense of sending a message. This is how they work. If I have char ch, I can say ch equals, I give it the name of the class instead of the name of an object. So I say character dot, and there's, for example, something called toUppercase that gets passed in some character and returns to you the uppercase version of that character. Just like we wrote toLower here, you can imagine you could do a very similar kind of thing with slightly different math to create an uppercase version. It does that for you. This method is part of a class called character, but it is what we refer to as a static method. It's not a method that every object in that class has. It's a method that just the class has, so the way we refer to it is we give it the class name and then the method name, because this ch, this char thing, is not an object. Okay? It turns out there actually is a class called character that you can create objects of, but we're not going to get into that. We're just going to use these little things called chars, which are our friend. And there's a bunch of useful methods in this character class, and I'll just go over a few of them real briefly. Okay? So real quickly, You can check to see if a character is a digit, is a letter, or is letter or digit. That's good for sort of validating some inputs if you want the user to type in something in particular. These take in characters and return booleans. Question? We're not going to worry about letters from different alphabets for now. But in fact, they're all supported. The numbers just get bigger for what they could be. I only showed you the first 127 letters. It turns out the standard that Java uses actually supports over 1 million characters. And so you can have all kinds of stuff like Chinese and Arabic and all that's all in there. It's good times. So in terms of other things you can do with characters, you can convert a character, or you can check to see if a character is lowercase or uppercase. And all these at this point, you should be like, Mehran, these are trivial. Like, I know how to write these myself. Yeah, in fact, you do, and you could. But they're so easy to write, they're just kind of given to you for free as well. A couple others, like is white space. That one's actually convenient. It checks to see if a character is either a tab or a space or a new line, for example, anything that would be considered a sort of space character. Question? It returns a boolean. So it just says the thing that you gave me is a letter or a digit. Like, for example, here's the digit 2. So it would return true for that. Except it might hit someone else along the way. Yeah, if it's either a letter or a digit. It doesn't let you know which one. It's just if it was a letter or a digit. Basically, it's not punctuation is kind of the idea. And then finally, 2 lowercase and 2 uppercase. You actually just wrote 2 lower yourself, but you also get those in there. These are all in the book, so you don't need to worry about copying them down, and the slides will be posted on the website. Okay? So characters are kind of fun because we can do math on characters, and it's kind of like, oh, that's sort of interesting. But it gets more fun when we can put a whole sequence of characters together into our friend, the string. Okay? So it's time to bring the string back out. Time to polish off the string. I actually want to just see if I can do this, just for laughs. I want to see how far it'll go. Sock. All right. Strings. I'm going to try that again by the end of class. String. It's just a major whiff recorded for all time. All right. So our friend, the string class. Strings, in fact, are a class, and there are objects associated with strings, as you sort of saw before. So we could have, for example, a string that we declare called str, and we might read that in from the user using our friend read line that you just saw an example of previously, and we pulled out individual characters. Here we're going to read a whole line. Okay? Now it turns out there's a bunch of things that we would like to be able to do on strings. The key concept with strings is a string is what we refer to as immutable, which means that a string cannot be changed in place. If the user types in hello, and I say, yeah, hello is kind of fun, but I really like Jell-O, and so I want to get rid of the H and replace it by a J, I cannot do that in a string. So if you've worked with other languages where you can directly change the context of a string, not allowed in Java. They are immutable. Which means if I want to go from hello to Jell-O, what I need to do is somehow create a new string that contains Jell-O. Okay? I might take some portion of this string and add some new character to it, and I'll show you some examples of how we might do that. But the key concept is strings are immutable. They cannot be changed in place. When we do operations on strings, what we're actually going to do is create new strings that are modifications of the previous strings we had, but we're still creating new strings. Okay? So I'll show you some examples of methods for strings in just a second, but I want to contrast between strings and characters just real briefly before we sort of jettison our friend, the character, and deal all with strings. Okay, so char, as we talked about, is a primitive type. It's not a class. Versus string is a class, so we have objects of the string type. Okay, so if I were to have char ch and I were to have string str, and I want to do something like converting to uppercase, for ch I have to call character dot to uppercase, pass in ch. Okay? I don't actually pass this message to ch because ch is not a class. It's a primitive type. I need to call this funky class and say, hey, class character, let me use your to uppercase method to create this character. In string, there actually is a string operation to uppercase. And the way that works is I could say string equals str. So the receiver of the message is actually an object, right? It's this string thing. I'm not writing out the whole word string. I'm saying str dot to uppercase, and I pass it in str. Now here, things might look a little bit funky. The first thing that looks funky is you say, hey, Mehran, if you're telling this string to convert itself to uppercase, why do you need to assign it back to itself? Why can't you just say, hey, string, convert yourself to uppercase? Why wouldn't that make sense in Java's model? Because strings are immutable. That's just beautiful. That gets 1. You're rocking. Oh, well, she gets 1. The basic idea, right, is strings are immutable, so I can't tell a string to change itself to an uppercase version. I can say, hey, string, create an uppercase version of yourself. You haven't changed yourself, and give me that uppercase version. So it says, oh, okay. Oh, sorry. I didn't actually pass in string here. My bad. Because the string is the receiver. I say, string, create an uppercase version of yourself. It says, here you go. Here's the uppercase version. And it's all excited. It's like, oh, here's an uppercase version of me. It's going to be like me and my uppercase version. And what do? You just say, yeah, it's not you anymore. I'm just slamming over you with your uppercase version. So I've replaced the old string with its uppercase version. But for a brief gleaming moment in time, I had this thing was a separate string. Until I assigned it over here, I wasn't actually overwriting or changing str. Okay? So if I assigned it to some other string like string 2, I would actually have the original unchanged in the string 2, which would be a different kind of thing. Okay? So a bunch of things you can also do on strings. Concatenation you've actually seen before. I'll show you one more example of concatenation, but you've been doing it sort of this whole time. I have string S1, which will be CS106. I have string 2. It's okay for a string to be a single character, A. It is distinguished from the character A by having double quotes around it. So character, always one character. String can be one or more characters. As a matter of fact, it can be 0 characters. You can have double quote, which is the empty string. And so I can create a new string, string S3, by just concatenating using the plus operation. So I can say, I got n plus string 2 plus in plus string 1 plus string 2. What is that going to give me? I got an A in CS106 A, and it just concatenates them all together. Right? Be happy. Be happy it's not like CS106 F. Right? Like, I don't know what's going on in CS106X, right? It's just like, I'm like, oh, X, is that good, bad? I don't know. Yeah, we're just dealing with the A here. And it's amazing how small the difference is between an A and an F. Just kidding. It's actually a huge wide gulf. I'm sure all of you will get A's. It'll be wonderful. All right? But plus is concatenation. Another thing you might want to do with strings is say, hey, the user is giving me some particular string, like I do a read line over here. Can I actually check to see if that string is equal to something? So one thing I might be inclined to do is say, hey, is that string, str, equal to some other string? Like maybe I had some other string up here, s2. And I might say, is that equal to s2? Turns out this looks like a perfectly reasonable thing to say. Bad times. This is not how we check for equality with strings. What this test, it's actually valid syntax. You will not get a compiler error when you do this. What this is actually doing is saying, are str and s2 the same object? Not do they contain the same characters, but are they the same actual object? Which most of the time when you're comparing two strings, they're not the same actual object. They are two different objects that may contain the same characters. So how do we actually test for equality? Well, there is a little method we use that is a method of the string class called equals. And the way we write it is kind of funky. We take one of the strings and we say s1 dot equals, and then we give it as a parameter the other string, str. Okay? So what it says is it basically sends the equals message to string 1 and says, hey, string 1, you know what your own contents are. Are they happen to be equal to the contents of this other string I'm passing you as a parameter? And this returns true or false if these two strings contain the same characters. It is case sensitive. There's another version of it that's called equals ignore case that is case insensitive. But this version is case sensitive. The other one you can also see in the book. It's not a big deal. Okay? So these are some very useful methods. I'll show you some more useful methods of strings very briefly. And we'll talk about some of these in more detail next time, but I want you to just see them briefly right now. The 3 made its way back up here. Oh, this was the one I whiffed. Yeah, just the grisly reminder. All right, so the string class has some methods like the length of a string. How many characters does that string contain, right? So for a particular string like str, you'd say str.length, and it would give you back as an integer the number of characters in the string. Char at, you already saw. You give it some index starting at 0, and it gives you back the character at that particular index. There's a couple things you can do substring, where you can pull out a portion of the string. Like remember our friend hello, where at some point we want to say, oh, I'll just slide this over. Where we have some string, which I'll call str, which maybe is set to hello. What the substring method actually does is it says, give me back a piece of yourself. And the piece of yourself is determined by some indices p1 and p2. p1 is the beginning index of the substring you want to get. p2 is the end of the substring you want to get, but not counting p2. So it's exclusive of p2. What does that mean? So if I say string dot, make sure I get the name right, substring, where I start at position 1, that's going to start at the E, because that's position 1. And then I say go up to, so here's 1, 0, 1, 2, 3. I say go up to 3. Okay? What it actually gives me back is L, okay, as a string. And so I can assign that somewhere else. Maybe I have some other string S. It does not change the string str because it's immutable, but what it gives me back is starting at this position, up to but not including this position. It's kind of funky, that's just the way it is. There's a version of it that only has one parameter, and if you specify just one parameter, it says start at a particular location, give me everything to the end, because sometimes you want to do that. You just want to say give me everything from this position on to the end of the string. Okay? A couple other things. Equals you just saw. This lets you know if two strings are equal to each other. You might say, hey, Mehran, I don't want to just check to see if they're equal. Can I do greater than or less than? Well, you can't do greater than or less than using the greater than or less than signs. Those will not work properly. What you do is use a function called compare to. And the way compare to works is it actually gives you back an integer. That integer is either negative, 0, or positive. If it's negative, that means one string is less than the other string lexicographically. If it's 0, it means they're equal. And if it's positive, it means one string is greater than the other string in terms of the ordering that you actually, what you send the message to and the parameter that you actually pass. But it allows you to essentially check for not only equal to, but greater than or less than as well in lexicographic order. Okay? Couple other things very quickly. Index of allows you to search a string for a particular character or some other substring. So you tell a string, hey string, I want the index of the character E in your string. And if I asked hello, the string str, for the index of E, the character E, it would give me back a 1. So if it finds it, it gives you back the index of the first instance that it found it. So if I ask for the L, it'll give me back a 2. It won't give me back the 3. Or I can pass in some substring like EL and say, hey, where's EL located? And it'll say it's located starting at position 1. If it doesn't find it, it gives me back a -1 to say it's not found. Okay? So just a few things that you should see, and we can kind of put these together in some interesting ways. So let's actually put them together in some interesting ways. So one of the things that's common to do is you want to iterate through a whole string to do something on every character in the string. So you might have some for loop into I equals 0. You're going to count up to the length of the string. So if our string is, let's say, called str, we'd say as long as I is less than str's length, and then we would add our little friend, the I++, out here at the end. I++. And so this is going to go through essentially indexing the string from 0 up to the number of characters that it has. And then inside here we might say char ch equals str dot char at sub I. And what that means is one by one you're going to get each character in the string in ch. And then, potentially you do something with those characters and then you're done. Okay? So something you also sometimes do along the way is you do some work and you say, hey, I want to build up some resulting string. Like maybe I want to take a string and create a lowercase version of it. Okay? So if I had some string str and I wanted to build up some lowercase version of it, I would say, well, I need to keep track of what my result is. So I'll start off with some string result that I'll set to be the empty string. So it's 2 quotes in a row. That's the empty string. It means there's no characters in that string. It's still a valid string, but there's no characters. There's not even a space there. And then for every character that I'm going to get in this loop, what I'm going to do is I'm going to tack on some version of it to result. So I might say result plus equals, which means concatenate onto the end of result. Essentially what this is really doing, you might say, but I thought strings were immutable, Mehran. Yeah, what it's really doing is creating a new string with an extra something added to the end and reassigning that back to result. Okay? So I might say result plus equals character dot to uppercase of ch. Let me erase this over here just so we don't get any more confusion. Okay? And so what this is actually going to do is it goes through this string character by character, pulls out each individual character, converts it to uppercase, and appends it onto the result that I'm building up. So at the end, what result will be is an uppercased version of the string that I'm originally processing. Okay? And this is an extremely common thing to do with strings. I mean, not necessarily converting them to uppercase, but pulling out characters one at a time, doing something on each character, and building up some result as a result. Okay? Any questions about that? Uh-huh. So I'm not checking the length of result. I'm checking the length of string. But the length of result, if I were to actually compute it, is 0. Yeah, I need to put the double quotes here to say that result starts off empty. Otherwise, I don't know what result starts as. Whoa. Alrighty. So last but not least, 2 uppercase and 2 lowercase, as I mentioned, returns to you a new string that is the upper or lowercase version of that string. So basically, we've just written over there the equivalent of 2 uppercase if we returned whatever result was. So let me show you one final example before you go. And that's reversing a string. So you might say, how might we reverse a string? So here's a little program that reverses a string. It's going to read in some line from the user, and it's going to call a method, reverse string, that as you can notice over here, reverse string can't change the string in place because it's immutable. So it's going to return to us a new string that we're going to pass, or we're going to store in this thing called reverse. So we ask to enter a string. We're going to enter stressed, because I think at week 4 of the quarter, by the end of it, most people are feeling a little stressed. And so we're going to call reverse string, and reverse string comes over here doing this funkiness that we just talked about, right? It starts off with some result, which is the empty string, and it's going to count through every character in our original string, but it's going to do it in a way so that by adding the characters one by one from the beginning, appending them on, it's going to actually append to the front instead of the back, and that way it's going to reverse the string. Okay, so that's the difference with this. This is appending on to the end, so you get things in the same order. Here we're saying take whatever you had in result before, and the thing you're going to add is a character at the beginning instead of at the end, which ends up reversing our order. So let's just go through this real quickly. I starts off at 0. It's less than length. I get the character at 0, which is going to be an S, and I add that to result. So nothing exciting going on there, right? Result was empty before. Now it's just the string S. Add 1 to I. Still less than length, and what I now get in the character at 1 is the t. I'm going to add the t to the beginning, right? So I'm going to say t plus whatever is in result, so now I have ts in my result. The t doesn't go on at the end. I'm appending it I'm putting it on, I'm prepending it basically. And then I add 1, I'm going to get the r now, add it to the beginning, and I keep doing this, adding the characters one by one at the beginning, and at the end, I now has a value that's greater than the length, right? Even though the length is 8, I has a value that's 8, and so it's not less than the length. And so I return desserts. And back over here, stressed still remains stressed, right? People are still stressed out. Now they're just eating a little dessert along with it. All right? So distressed spelled backwards is desserts. Okay? Uh-huh. You can actually multiply and divide characters. It's just sort of meaningless if you do. If you do, you sort of get the F. Yeah. Sorry, that's just life in the city. I'm sure you won't get an F, but you won't be multiplying characters either. Okay. One final thing. We still got a few minutes. It's like one of those, like remember we talked about how education is one of those things that like if you get less of it, you're happy, right? Like if you bought a car and the car had 3 doors, you'd be really upset if it was supposed to be a 4-door car because you'd be like, I paid like $10,000 for this car and it's only got 3 doors. Like it's missing one of the doors. But like if I let you out of here like 5 minutes early, you'd be like, woohoo! rock on, less education, same money. I've never been able to understand, well, actually I did understand that about 15 years ago when I was sitting there. But now I don't understand it anymore. I want to give you one more quick example, which is computing a palindrome. Okay? Oh, yeah. So what we're going to do is write a function that computes whether or not something is a palindrome. Do you know what a palindrome is? How many people know what a palindrome is? Show of hands. Yeah, it's a word or phrase that is the same forward or backward. So most people know what it is. Now I will ask you the more difficult question. Who created the world's longest palindrome? No, it was not me. Yeah. It was actually, however, my old boss, interestingly enough, a guy named Peter Norvig, who claims to have created the world's largest palindrome on November 23rd, 2003. And it's a palindrome that is 17,259 words long. Yeah, he did it with a computer. Oh. Sort of like if he was sitting there by hand, he's like, no, that one's not quite right. Yeah. 4 years later, it's like, Peter, are we going to have performance reviews this year? He's like, no, shut up. I got to add another word. Yeah, no, he's actually a wonderful guy, wonderful guy. But created the world's longest palindrome. And you could probably create one that's longer using a computer. But how do you actually determine that something is a palindrome? Okay? So we're going to just do a little bit more math on strings than we might have otherwise done. So here's a function that computes is something a palindrome, and we pass it a string. Now to figure out if something's a palindrome, it has to be the same going forward and backward. Which means to do that, one simple way of doing that is to say, hey, something like the word race car is a palindrome. Right? Woo, race car, right? One way I can figure out if it's a palindrome is I just say, is the first letter equal to the last letter? If it's not, I stop immediately. And if it is, then I check the next letter with the next to last letter. And I keep doing this. Now the question is, how long do I keep doing this, right? How long do I need to keep doing this for? The length divided by 2, right? I don't need to do it the whole length because eventually I'll cross over and I'll just redundantly check the other side. But if I check halfway this way, it means that if I was comparing the characters pairwise, I also checked halfway that way. The other thing that's fun about this is if I happen to have something that has a length 3, right, like the word bib, right, has a length of 3, the middle character is always equal to itself. So I don't need to check it. As a matter of fact, if I took the length 3 and divided it by 2, I get the integer 1, which means you only really need to do one check of the first letter and the last letter. And if those match up, don't even bother checking the middle. So it works nicely for words that have an odd number of letters by just optimizing out. It's a very small optimization, but optimizing out that middle character. And if I actually have 4 letters, like, what's a word with 4 letters that's a palindrome? What? New? Noon. I was like, new? New? That's like when you're a computer scientist, everything sounds like new. Noon. Thank you. You get the A for that. I was getting the F. Noon, right, you actually get 4 divided by 2. You need to do 2 checks, and that'll actually check all the characters you care about. So that's what we do here. We have a for loop up to the length divided by 2. It's doing integer division. And what we're going to do is we say, is the character at the beginning or at index I equal to the character at the end? Because we start counting from 0, the character at the end, if it has a length of 9, is actually at index 8, which is why we have this extra. When we do the subtraction, we add an extra 1 there. It means subtract off an extra 1, because if your length is 9, you really want the 8th character. And so basically, as I increases, we check increasing characters from the front and decreasing characters, because we're subtracting off I from the back. As soon as we find a pair that doesn't match, right? So as soon as these two things are not equal, we say, hey, I don't need to check anymore. I return false in the middle of the function, which means the rest of the function doesn't need to worry about. All the local variables get cleaned up, and I return false, because as soon as I find it, I don't need to say, hey, let me just check the rest just for laughs. It's like, oh, you were just one character away. Ah, ha, ha, I checked all the other ones. No, we just put you out of your misery immediately, and we return false. If you manage to make it through this for loop, it means you never hit a case where the 2 characters you were checking were not equal to each other, because if you did, you would have returned false. So if you never return false, you're good to go. You completed the whole loop, and so you'll return true at the end. Okay? So any questions about that? Alrighty. I will see you. Have a good weekend. I'll see you on Monday. And if you want a B or an E,